doing a presentation on global warming and what it does to the oceans, and then some alternatives to kind of like help the ocean. Right, anyway, just a few points first of all on why the oceans are so important and why sustaining them is so vital. Firstly, oceans play a critical role and give us elements which we need to survive. Ocean plants produce half of the world's oxygen. The oceans also regulate our weather and form clouds which bring us fresh water.
He's still thinking of panic attack.
Ocean ingredients are in pretty much everything that we kind of use. Like they're in shampoos, cosmetics, medications for like cancer and stuff like that. So, what else? 1 in 6 jobs are in the United States are marine regulated as well. Is that right? Related, that's the one. And $128 billion in GDP is annually resulted from the tourism which the ocean kind of brings in. Right, anyway, first slide.
I've got some pictures, go on, what's that?
Oh yeah, there. So we've got the picture of the well-known P.Valender from so I want to talk about acidification first. In the past 2 centuries, at a pace which is kind of like unprecedented to the geological record, the chemistry of the oceans has changed dramatically. As you can see, seawater is approximately 30% more acidic. I think approximately 10 years ago, the pH of the ocean was about 6.7, and it's estimated that in the next like 15 years it will actually get to an acidity value of about 8.0, 8.1, which is
That's up.
well.
8 is up.
No, sorry, no, it was 8 first, and now it's getting to 6. That's the one. Anyway. So yeah. Anyway, the increase in the acidic values in the seawater also has a major effect on sea creatures themselves, such as it actually dissolves their shells and exoskeletons, because obviously like quite a lot of like mollusks and stuff are made out of literally out of like kind of cartilage. And this obviously will have a major effect on the marine biosystem. So yeah, just a bit more generally about acidification on like mollusks. There's a special thing called petropods. These are petropods. They're basically called butterflies of the sea. They're about the same size as a small child's fingernail, so pretty small. But they basically anchor the food web in the ocean, if you know what I mean. They're like the anchoring point. So they're majorly vital. And basically, there has been some tank experiments, and in these experiments that have been conducted, the acid in the water has pretty much like just eroded their shells, like started making this like curling effect as well. Also, in areas such as the Pacific Northwest, acidic seawater has proved fatal to oyster spawns, and this continuing acidification, if it continues, will affect fisheries and ecosystems as well as coral reefs. Coral reefs, if anyone doesn't know, they're pretty much deemed as like the rainforests of the sea, just due to kind of everything that they do. Right, causes of acidification. The cause of acidification is pretty well understood. Since the beginning of the industrial era, the oceans have absorbed more than a quarter of the CO2 we've released in the atmosphere. Obviously quite a bit. Obviously due to burning of fossil fuels and other things. Obviously, when the CO2, or carbon dioxide, mixes with seawater, it forms carbonic acid, which is obviously explained in this little diagram. Yeah? The atmospheric carbon dioxide and the carbonic acid and little shells, I think. So, there is no easy solution, but geoengineers have proposed an idea. Basically, they are proposing to dump 300 million cubic feet of limestone, which is pretty much like a mega dose of geological Alka-Seltzer, I think that's how they pronounce it, into sea. But obviously there's like concerns just due to it only the benefits would only be temporary, and there are side effects, and the amount of money it's going to cost to produce the alkaline antidote as well is just like ridiculous. So it's kind of like a bit out there. So there is a suitable plan that someone's come up with. A lady called Miss Powell, who is a researcher at Woodhull Oceanographic Institution in Massachusetts. She has come up with the possibility of basically, it's to do with the US. They've got this tax code, and the dirty burning of fossil fuels remains cheaper than better, less damaging, cleaner alternatives. So they are coming up with a carbon tax that they're going to give to the American people. This carbon tax, they're basically going to tax companies, or they estimate it, if they tax companies $12.50 per tonne of CO2 that they produce, it will reduce the emissions by a staggering 30%, which will keep approximately 214 million tonnes of pollution out of the ocean. Although this won't completely bring acidification to a stop, it would definitely buy some time to look for other alternatives. Another one. So, really spoke about that. Other alternatives. There is a process called ion fertilisation. It's also called ocean seeding, carbon sinking. So two companies have kind of come up with this idea, them being Klimos and Planktos, random names of companies, but and yeah, they're basically just trying to, the iron is going to hopefully reduce the atmospheric carbon dioxide levels, and in turn this will reduce temperatures circulating the atmosphere. So basically the step for this iron dumping technique is just because iron kind of acts as a fertiliser for many things such as plants, and some of these such things like phytoplankton, which basically form the base of the marine web. and they need iron to grow. Therefore, adding iron to the water in the ocean stimulates the phytoplankton growth, which in turn they sort of gobble up the carbon dioxide through ways like photosynthesis. The resulting decrease in carbon dioxide helps reduce the temperatures, as carbon dioxide is one of the many gases, but more frequently deemed one of the main gases responsible for that of trapping heat on the Earth's surface due to the greenhouse effect. So this is just a little diagram of the iron there. Phytoplankton kind of suck it up, and then basically what the idea is behind this is, everyone can see, kind of. So the iron goes in, the phytoplankton kind of synthesise, and then they somehow kind of like suck in the CO2 themselves, and then they die, and then obviously go to like the bottom of the ocean floor because it's so far down. They kind of just die, and the carbon dioxide kind of like infiltrates into the rock, like the seabed layer, if you know what I mean, and then hopefully that will stay there for about 100 years. So it's just kind of taking it out and leaving it. Numerous amounts of iron dumping trials have been conducted since the oceanographer John Martin suggested the idea about 15 years ago. One trial in 2004 indicated from its results that each individual atom of iron added to the water could draw between 10,000 and 100,000 atoms of carbon from the atmosphere. It's pretty good. By encouraging the phytoplankton growth, a large amount of scientists also have theorised that the addition of iron to such areas as like the Southern Ocean could reduce carbon dioxide levels by 15% alone. Pretty good.
Just surprised by it.
Right, Oliver Wingenter and DMS. DMS is also kind of stands for dimethyl sulfide, and Oliver Wingenter, he's just some pretty clever guy, basically. Right, so another scientist of the name of Oliver Wingenter has argued that by adding large amounts of iron to the ocean, it could cause a cooling response of about 10 degrees C. Mr. Wingenter therefore has recommended that just 2% of the Southern Ocean is fertilised, which should cause a cooling of around 2 degrees C, and this will kind of, hopefully, set back the tipping point of global warming for longer than approximately 10 years. Instead of completely basing all of his research into carbon dioxide, Mr. Wingenter research also concentrated on increasing different gases from the
Phytoplankton.
Yeah, that's blooms. One such gas being that of the DMS, or dimethyl sulfide. DMS is largely attributed to cloud formation in areas such as the polar region, and may increase the reflectivity of clouds, which could also bring around a reduction in temperatures. When Wingenter was carrying out his experiments in the field of iron fertilisation, he found that the adding of iron increased the concentration levels of DMS fivefold. And that is about it. So, the outcome, we've got to look after the oceans, and then happy crabs and mollusks and stuff.